at some point it starts to sound like a cult, you know, and you're like, oh, I don't know if I should. Okay, so that's enough poor attempts at stand-up comedy for me. I'm glad you're feeling good. I'm glad you're still awake. I noticed a few empty seats here. Where's everybody else? Toms, you should go and like whip them. And anyway, I'm glad for those of you who stuck around. Hey, I'm excited for this talk. You know why? Because this talk is about IoT. We haven't had an IoT talk here. And so it's IoT and Kubernetes at the edge computing. Wow, I'm super excited. Who else is excited about edge computing here? See? This is for you. This is for you. So without further ado, give it up for your next speaker.
So, can you hear me? Yeah, perfect. So, hello everyone. Thank you all for joining today's conference. Here you see the title of my talk. It's about Kubernetes at the edge, IoT Edge Computing. And before we start, I want to introduce myself short. My name is Onur Kasimlar. I'm working for Poseidon GmbH, and I'm working there as a software architect and DevOps engineer. So the target of this talk is to show briefly how we can automate deployments and manage containerized applications at the edge using Kubernetes. There is not such a big difference in using normal Kubernetes and using Kubernetes in an edge environment, but we will see this. So, if we search on Google with these buzzwords like IoT or edge computing, then we get an image like this maybe. At the bottom, we see the IoT devices which connect to the edge node, and the edge node which then have this connection to the cloud. In most cases, edge computing is used to process time-critical processes to avoid latency between the edge and the cloud. But edge devices are also used to filter data before they are sent to the cloud, just to save memory there, because maybe they are not needed. Anyway, so what kind of problems may we face when we look at this architecture? I mean, the single point of failure is clear. If we have only one edge node, we can put another one and do some kind of load balancing. That maybe then we will get rid of it. Then self-healing applications, I don't know if you can manage this maybe in the cloud, because there we already have some kind of services for exactly doing this stuff. But on the edge, you won't have them, so maybe you have to write your own software to manage this, which can also fail. And avoiding downtimes when deploying to the edge, also there, you need some stuff. And automated deployments, rollouts, and rollbacks. For all, there are tools on the market to fulfill all these non-functional requirements, but why shouldn't we use Kubernetes, only one single tool, to fulfill these non-functional requirements? So, what is Kubernetes? So, in only one single sentence, we can say that Kubernetes is an open source orchestration platform for managing containerized workloads and services. And what problems does Kubernetes solve actually? Yeah, all of these listed bullet points we get out of the box with Kubernetes. So Kubernetes solves the problems which come with the containerization. With Kubernetes we can avoid downtimes out of the box, and also scaling is not a problem. Self-healing and service discovery and load balancing, and a lot of more stuff like automated rollouts and rollbacks. So here we have Kubernetes architecture. We have one master node, two worker nodes. Of course, in a productive system, it might be the case that we have multiple master nodes and maybe more worker nodes. The master node is also called the control plane of Kubernetes. And in the next slides, I'm going to introduce these components slightly, briefly, sorry. But first of all, containers. How many of you guys already have worked with containers or know what containers are? Nice, then we can skip this slide. Okay. First of all, I want to start with the pods. The pods are the smallest execution unit in Kubernetes. They are wrapping, in most cases, only one container, but it's also the case that you can use multiple containers in one pod, just in case of, for example, when you need a proxy for the one container, you can have a second container with the proxy. And if a pod fails, then for any reason like a software error or if a memory error and so on, the software will be restarted, the pod will be restarted with all of the containers. And the kubelet is the primary node agent. It registers the node over the API server in the cluster, and it also manages the container and ensures that the containers are healthy and running. If not, the kubelet can restart the pod so that the container become healthy again. And kube proxy is also installed on each node. This kube proxy is also called network proxy. The main purpose of the network proxy is to do load balancing in the cluster. So when we imagine that we have two replicas of the same container running in the two different nodes, then it might be the case that kube proxy in node 1 redirects the request to node 2. The API server. The API server is the core of Kubernetes control plane. It exposes an HTTP API that lets end users, different components of the cluster and external components communicate with each other. So we can query and manipulate the state of the objects in the Kubernetes cluster with REST, but it's also possible to use some command line tools like kubeadmin or kubectl to create new pods and so on. And the ECTC store, actually this is only a key value store. It's highly available and it's the backing store for all cluster data. Important here is that the value store is only accessible over the API store. So all the components in the cluster have to access this, or if they need to access it, must do this over the API server. The control manager. The control manager is a daemon running in an endless loop. It's responsible to regulate the state of the system. It watches the current state and makes the changes if the desired state is not reached. So if there's a node missing, or in the sense of the cloud, or if there's a pod missing, the control manager will recognize this. Last but not least, we have the scheduler. The scheduler is the component which decides to which node a pod will be installed. So a scheduler watches for newly created pods that have no node assigned. It's the responsibility of the scheduler to find the best fitting node for the pod which we want to deploy. And what does mean best fitting? Just very interesting here. So best fitting might be the memory or also the processor units we have available on one node. But if we say that our software runs better in with a GPU, then it might be even that. But it does not have to be hardware to decide. So it might be also the location, so the destination actually, when we say we want to have this pod installed at the edge. This is often the case if you really have some software, some components, some containers which really have to run only there. We can say, look, we want this to run at the edge node. How we can achieve this? It's very simple. Actually, we can use node labels. Node labels are key value pairs. We can say, look, the nodes at the edge side, we label them with destination edge, and the one in the cloud, we can say, these are destination cloud. And if we want to have a node with the destination edge, then the scheduler must find one of them. We can reduce, we can also say that this is our preferred destination. So if there's nothing available on the edge, then we can say, okay, we install this node in the cloud, and as soon as we have enough place, enough resources on the edge, then it will be reallocated. So, and if we use Kubernetes and spin up a cluster over the cloud and the edge, it might look like this, and we would absolutely profit from the out-of-the-box solutions coming with Kubernetes. There are also a bunch of tools for IoT and Kubernetes which optimize specific challenges with edge computing and cloud computing. So, for example, we have these tools I mentioned here, KubeEdge, Q3S, micro Kubernetes, and so on. And I also have listed some of these problems we might face. So it might be the case that we don't have enough memory at the edge side, or that we don't have the correct processor where we can install Kubernetes and so on. Or we need some kind of MQTT to connect to some sensors from IoT stuff. So we can use one of these tools. To have a deeper dive into this, I would need much more time. So if you have any questions about it, I will be here, and I would be happy to talk with you about this kind of stuff. Thank you very much. I hope, I'm in time, that's nice. Do you have any questions, please?
It's amazing how you condensed so much information into such a short talk. Appreciate that. Really cool. Question, one question. Time for one question. Going once, going twice.
Thank you.
Okay, well, he's going to be around at the party, right? Yes, he hopes so. What does that mean? That sounds a little bit. You hope so. You're going to get like taken to heaven on a. Okay.
I will be here. Yeah.
Awesome. He's going to be there at the party. So please feel free, grab him, ask some questions. It's a really interesting topic. Thank you again. Let's hear it one more time, everybody. That's excellent.
Thank you all.
Excellent.